So in this video we are going to look at the conservation of mass, which is part of the CC9 calculations topic and can come up on paper 1 or on paper 2. So I have written out a balanced equation for you. You can see that you've got 1 magnesium on each side, you've got 2 chlorines on each side, you've got 2 hydrogens on each side. Because you've got the same number of atoms on each side of the reaction, you will also have the same mass on each side of the reaction. So if I look at what I've got here on my left-hand side, collectively, these are called the reactants. And on the right-hand side, what I'm forming are called the products. If the mass of the reactants was, say, 200 grams, okay, so combined, the magnesium and the hydrochloric acid gives you a mass of 200 grams. Then the mass of the products combined will also give you a mass of 200 grams. Okay, the mass is the same on both sides of the equation. Mass is conserved, and the reason is you've got the same number of atoms on each side of the equation. They've just been rearranged, and because you've got the same number of atoms, you are going to have the same mass on each side of the equation, on the reactant side and the product side. So you can use that law, okay, if we look at another example. Just say I reacted 20 grams of magnesium with 10 grams of hydrochloric acid. You're told in the question that you formed 15 grams of magnesium chloride and they want to know how much hydrogen you formed. Well, if I add the mass of my reactants, I will see that the total mass of my reactants is 30 grams. I know that if I've got 30 grams of reactants, then I must have 30 grams of products. I've got 15 of magnesium chloride. That must mean I also have 15 of hydrogen. Okay? If we look at another example, and the equation looks, a little bit more complicated, but the principle is going to be the same. If I'm starting with 15 grams of aluminium and 5 grams of sulfuric acid, then in total I have got 20 grams of reactants. That means I'm going to form, in total, 20 grams of products. Okay? And I haven't given you any individual information about either of the products, so the question would just state, if you reacted 15 grams of aluminium with 5 grams of sulfuric acid, what would be the mass of your products? Got 20 grams in total on the reactant side, therefore you must have 20 grams in total on the product side. And we can write this as the law of conservation of mass, which just says that the total mass of the reactants is always equal to the total mass of the products. Okay, that's the law of the conservation of mass. Boom. However, you can have situations where it appears as if the law of conservation of mass is not holding true. So if we go back to the original equation where I had magnesium and hydrochloric acid, I've got that here in a conical flask. I've got 20 grams, let's say, of hydrochloric acid, and to that I'm going to add 2 grams of magnesium. In total, if I had my conical flask on a mass balance, I would see at the start of the reaction, I've got 22 grams. 2 grams of the magnesium, 20 grams of the HCl, 22 grams for the reactants. I carry out my reaction and I form the products, magnesium chloride and hydrogen gas. The products form here in my conical flask, but when I look at the mass balance, I see that I don't have a mass of 22. I've actually only got a mass of 17 grams. It looks like the law of conservation of mass is not holding true. I've started out with 22 grams of reactants, yet I'm only forming 17 grams of product. So what's happening here? Well, if you look at the equation above, you'll see I've included state symbols this time. Magnesium chloride is aqueous, so it's a salt dissolved in water, and it is all still here present in the flask. But hydrogen is a gas. And because I'm carrying this reaction out in an open system, so an open conical flask, when that hydrogen gas is formed, it can escape from the conical flask. So all of the hydrogen gas that's being formed escapes. And because my product is escaping the flask, it is not counted in the mass, and it looks as if the mass has decreased. So what they could ask you here is they could ask you to explain why the mass of the products appears to be lower than the mass of the reactants. And you would say hydrogen is a gas, and the gas can escape from the open flask. They could then ask you to calculate, well, how much hydrogen gas has escaped? And you will see that you started with 22 reactants. You would expect to have 22 grams for your products. You've only got 17, therefore 5 grams of hydrogen must have escaped. You could also have a situation where it appears as if the mass is increasing. And typically when they're talking about the mass increasing, they'll talk to you about reacting magnesium with oxygen. And if you want to react magnesium with oxygen, you will burn magnesium. You'll place some magnesium in what is called a crucible. So you'll put some magnesium into this little pot called a crucible. So let's say I'm starting out with 10 grams of magnesium, and I put it in my crucible, and then I heat my crucible. And then they will say that after you've finished heating your magnesium, that you reweigh it, and you will find out that when you weigh your crucible with your magnesium inside, that instead of having just 10 grams of magnesium, maybe you've got 13 grams now. And they could ask you why. Okay? When you are heating the magnesium, what is happening is the magnesium is reacting with oxygen. So it's not enough to just say magnesium reacts with air. You would have to specifically say that when you heat magnesium, when you burn it, it reacts with the oxygen from the air. And when magnesium reacts with oxygen, it forms magnesium oxide. The reason the mass has increased, so you started off with your 10 grams of magnesium, the reason it's increased to 13 grams is, as you can see on the product side, you don't just have magnesium anymore, you've now got magnesium bonded to oxygen. So the magnesium has reacted with oxygen to form magnesium oxide. The magnesium oxide has a greater mass than the original magnesium because it also includes the mass of the oxygen that the magnesium reacted with. You can work out how much oxygen it reacted with, because you know if you started with 10 grams and you're ending with 13, then it must have reacted with 3 grams of oxygen. Okay, so it might appear that the mass is increasing, but if you heat magnesium, you're causing it to react with oxygen from the air, and in your end product, you've got the mass of the magnesium plus the mass of the oxygen, which is why you've got an increase in mass. So I have got written here 2 worked examples of these questions. So example 1, explain why there appears to be a loss in mass in the following reaction. So there's a reaction here. You look at the products, you see that one of the products is a gas, and then you say CO2 is a gas and can escape from an open system. So you must mention that you've got a gas, and you must mention that that can escape if you've got an open system. By open system, I mean that there's no lid on, okay, that the gas is free to escape the flask. The next question, when magnesium burns in air, it gains mass. Explain. Magnesium has reacted with oxygen. You must specify the oxygen. Can't just say it reacts with air. Magnesium has reacted with oxygen and so has gained the mass of the oxygen and formed magnesium oxide. Okay, so that would be your 2 marks there. I'm going to get you to do some practice questions on this now. There's no point in just sitting here watching the video thinking you understand everything and not doing any practice questions. You don't really know what you know until you've done a few questions. So I've shared some questions with you here on the screen, all related to conservation of mass. Have a go at these 6 questions. Press pause, have a go, and when you're ready to see the answers, press play. Okay, so here are the answers, and apologies because I realised in question 10 that you couldn't see the equation that you needed to see. But in question 10, when you reacted magnesium and hydrochloric acid, you are producing hydrogen gas. If you react a metal and an acid, you produce hydrogen gas. Because hydrogen is a gas, it can escape from an open flask. So anytime you're asked about the mass appearing to decrease, you're going to be talking about a gas escaping from an open flask. In question 11, you were first asked to name the product, so you had to be able to read the symbols. Water and carbon dioxide should have been fine, and then KCl was potassium chloride. Again, why is there a loss of mass? Carbon dioxide is the gas in this case, and it escapes from an open flask. And you were told the mass of the reactants and then the mass of the products, and you should have been able to see that 11 grams of carbon dioxide was escaping. In the next question, so I'm just going to lift this up. In the next question, question 12, this is similar. You were asked to calculate the mass of oxygen that combines with magnesium to form magnesium oxide. You're given the mass of the magnesium oxide, you're given the mass of the magnesium, subtracting one from the other gives you the mass of the oxygen. Okay, it's the same in question 13 when you're reacting aluminium with oxygen. The mass of the product minus the mass of the aluminium gives you the mass of the oxygen. In 14, this is a common question. If you take two solutions and mix them together, you form a solid. It's kind of like a common misconception that the solid must be heavier, must have a greater mass, okay? But it doesn't. You can answer 14 by just stating the law of conservation of mass, okay? Because the total mass of the reactants equals the total mass of the products, you're going to have the same mass. It doesn't matter that you're changing state. Okay, so I've written here in brackets that it doesn't matter if you form a solid, you still have the same number of atoms present, the mass will be the same. But you would answer this question by just stating the law of conservation of mass. And then the last question, again, I told you you're adding a metal to an acid. You're going to produce hydrogen gas if you react a metal and an acid. To prove it's hydrogen, you insert a lit splint and you will hear a squeaky pop. So these are 2-mark questions. You don't get any marks for mentioning squeaky pop alone. You don't get the squeaky pop mark without the lit splint. And then again, why does mass appear to decrease? Hydrogen's a gas, it escapes from the open flask. Those questions are all answered in the same way.